packet, folks. You're on the packet that up at the top it says 7.1 solve the system. These are your notes. I know that I have given you a couple of other things. One is extra practice and one is the practice test. No egos right now. We haven't started the lesson yet. We're starting the lesson with the notes. It says 7.1 solve the system. Okay, that's where we're starting. Now, this first lesson is incredibly easy, hopefully, to you. We're solving systems of equations, and a system of equations is simply two or more equations. We're solving a system, and I have stipulated on the sheet how you're to solve. Now, on the test you just took, did you have to solve a system of equations? Yep. And every time I did that, every time I did elimination because the problems were just set up that way. You don't have to do elimination every time. So we're going to start, in fact, by going through and doing all of the substitution problems. So, problem number 1. And again, we are in our notes. It says 7.1 in a box. It says solve the system. And the first problem is right here. Who remembers how to substitute, how to use substitution? What do we do, Lauren? Exactly. So you pick a variable to get by itself. And always, if you can, if you have this option, always choose the variable that doesn't have anything attached to it. So for example, don't pick this 2y. That would not be smart, because to get y by itself, you're going to have to divide and you're going to end up with fractions. It's not that it's not doable, it's just it's a pain. So here's a nice letter that's all by itself. Nothing attached to it. So I'm going to get it by itself, so it's x equals. So I'm going to take this top equation, I'm going to move 2y to the other side, so it looks like that. Would you all agree with that? Then I will take this guy and substitute him in right here. Because since this is what x equals, I'll just put it in place of the x. Now, why would I do that? What's nice now about this equation that I have left when I substitute that in there? I don't have an x, I only have one variable. And the key is, kids, you only want to have one variable. You can't solve if there's two, right? So we got to get rid of one of them, so we substituted it out. Now we'll do our distributive. Distribute. We'll go ahead and collect like terms. And I'm not going to make careless mistakes. -4 and -1 makes -5. Now what? Subtract the 8. Remember, that's going to be -5y equal to -5. So y equals 1. Now, you are not done. Do you remember what else you have to do? You have to plug it back in. Anywhere, any of the originals or this one. I like to put it in this one, because when I plug in 1, I see that x will equal what? 2. 4 minus 2. And then anybody remember how you write your answer?
No.
As an ordered pair. That's exactly right. Does anybody know why you're writing your answer that way? Brendan?
Because those are line functions.
Exactly. These are lines. And when we solve the system, what we are looking for is where they cross. And so that answer is going to be a point. 2, 1. Make sure when you write your answer that it's always x, y. All right, is that starting to come back to you a little bit? Yeah. All right, let's see. I'm doing all the substitution ones. So the next one is this one. Now this is not a line. I mean, this is a line, but what's this shape? A parabola. So now we're looking for where a line and a parabola cross. But that doesn't change the way I do the problem. See how y is already by itself?
Plug it in.
So I'm going to take this and plug it in right here. This is y. This is what y equals. So I'll just plug it in right there for the y. So x plus 1 squared equals 5. Pretend you have a big pair of scissors. You just cut this out and paste it right on top of that y. Now what do I do? So I gotta FOIL it. That's a FOIL. This is a FOIL. Do not make a first algebra mistake and just square these things. That's not how it works. You have to FOIL it. Yeah, so it's x squared plus 3x. Now, I'm going to go ahead and move the 5 over because I like to have my quadratic equation set equal to 0. And what do I mean by quadratic equation? X squared. So what does that mean? Minus 4? You don't have to use the quadratic formula. You can. But I think this one factors. Does anybody see it? If you don't see how it factors, then use the quadratic formula. But it looks like it's going to factor as x minus 1, x plus 4. Oh my gosh. That means I have 2 x values. Right? That's odd. Let's see. If I put in 1, I get 2. And if I put in negative 4, I get negative 3. So 1 comma 2 and negative 4, negative 3. Why did I get 2 answers? Well, remember, it was a parabola, and the lines, how many places do they cross? 2. Maybe 2. It wouldn't have to be 2, but it certainly could be 2, right? And it is 2 in this problem. You will never get 2 answers when you have 2 lines. But if you have other shapes, you might get more than 1 answer. One more substitution. We have number 6. I'm doing all the substitution ones first. So number 6. All right, who's got an idea? We're going to do substitution now. So what do you think? Punch for Q. See, wake him up. There we go. Thank you. Keep your head up, honey. Anybody have an idea? Anthony. Add the y to the other side. Yeah, that would be a great idea. So x equals 4 plus y. And then what do we do, Solomon? What do we do now? What do I do?
Bless you. Love you.
Okay, that's why I need you to pay attention. Okay? I need you to pay attention. Janaea?
Plug in a 4 plus y for you.
Exactly. So x is 4 plus y, so I'm going to put it in right there. Okay, don't put it in up here, that's that equation, we already did that one. Plug it in the other equation. So 2y minus 2 times 4 plus y equals 3. Does that look okay to everyone?
Yes.
Now, when you do your distributive, watch it. It's going to be negative 8 and negative 2y. These cancel out
As they should.
and leave me with negative 8 equals 3.
Oh, there's no solution.
Exactly. What is going on? We got no solution. What is happening?
The lines never intersect.
The lines don't intersect, which means they must be parallel. We have a pair of parallel lines. The algebra tells you that because this is impossible, which means the lines never cross, which means in 2 dimensions they are parallel.
Okay, so do you want us to write parallel lines or no solution?
Whatever flips your switch. All right? Okay, so that takes care of the substitution. Let's look at the elimination.
Quiet, John.
As he should.
Okay. We're not acting very mature right now. Here we go. We're going to solve this system using elimination. Now, remember what that means. That means you're going to add them together. In fact, the process is sometimes called addition, the addition method. We're going to add them together and eliminate a variable. Adding them right now would make a 7 and a negative 2. Nothing's eliminated. So you're going to have to do something to make the elimination happen. Brendan?
We multiply the bottom equation by 3.
If you multiply the bottom equation by 3, Brendan says, and leave the top equation alone, now when you add, you see what happens?
Wise cousin.
Now, this process is so simple. You've been doing it since you were very young. But kids make mistakes because they forget that when you times by 3, it's everything in the whole equation. It's times by 3. Okay, so 17x equals 85. So x equals 5. Then we do what we did before. We go back to some equation. It doesn't matter which one. Go back to some equation and put in 5. I got negative 1 if I did my arithmetic correctly.
That is correct.
And so then I'll write my answer down, 5 comma negative 1. What if someone didn't follow directions and did this problem with substitution? You're going to get the same answer. So it's not, the answer isn't going to change, it's just the process you're using. Okay, try it, number 4, here we go. Now, don't panic. These are squared terms, but they can eliminate too.
Good afternoon.